Let's move on to the next item on the program. If we can revisit this at some other time, we will. So now it's David Cabanellas talking about fish protein hydrolysates.
Okay. Hello, good afternoon to everyone. And well, I would like to thank the possibility to be here today and well, explain from our point of view the potential of these hydrolyzed protein concentrates from the aquaculture in Galicia. Okay, just to briefly introduce who we are and why we are talking about this, Valora is a company that grew and started based on marine products, on wild fish, but recently we have been studying also the potential of aquaculture products for different applications. This story started a long time ago in order to make use of 100% of the fish that we receive in our factories. The point is that what makes the difference between the head and the loin, and it's all about a matter of perspective, right? So head nutritional wise is as interesting as it could be a loin, but the customers are not ready to eat a head, right? So we have to prepare and follow the market trends in order to present the head in a different way. Well, we manufacture different products, but basically everything comes from a raw material. We make an extraction, concentration by different types, sterilization and packaging, and we are sourcing different industries. But for example, we manufacture baits for fishing based on fish, so it's a little bit similar to the previous speaker that was talking about circular economy. We are manufacturing natural seasonings, functional ingredients, products for the primary sector, such as fertilizers, and pet food and feed. So basically, just to introduce a little bit the market and what is the size of the lake, and what are the current products that are for the delivering protein for feed or food applications. So on the lower part of the pyramid, we have the commodities that are the fish meal is the main one. That this is a huge production worldwide, ranging from 4,000 million tons to 5,000 million tons, and with a important share of the fish meal coming from the fish direct fishing, and another smaller part coming from trimmings from other processes. Then we have the specialties that are the hydrolysates and other specialty meals, with a price ranging from 1.5 to 3 euros or $3 per kilogram. And finally, we have functional peptides that have some bioactive activity, and this activity has to be proven, and then you can have a scale up in terms of pricing. The way to get the process we follow in order to get the hydrolyzed protein is we start with a line segregation. I mean, it's important to have control on the stream because each byproduct has different characteristics. Guts will be different to heads or to skins, whatever. So it's important, in order to have the most stable product, to have well identified what are the parts that are going for the hydrolyzed process, whether it could be 100% of them, or maybe you want to deliver a more specific product, so you decide to just deliver a part of your byproducts. So after this line segregation, you proceed with a cutting, hydrolyzed reaction, the reactors. Afterwards, you come with a filtrate or decantate first. But basically, you separate the solids, the non-soluble part, which are mainly bones, if you are placing frames or other parts that have more bones, and the filtration in order to avoid to further use of the as big particles that are not interesting in the next stage of the process. So basically, after this filtration, we go for a concentration. And basically, the hydrolyzed protein could be solved in 3 different ways. One is directly liquid, as it gets found for the reactor, with a lower value. Second possibility is concentrated, which needs to be acidified in order to be stable, to be self-stable. And the main one, which is the drying, usually by spray drying methods or drum dryer. So basically, what is the size of this market? So basically, the hydrolyzed protein market has a value of 210 million US dollar with a volume of 127,000 tons. As I said before, in terms of value, the dry products represent 52% of the market, but the volume is at 35%, which also gives you the impact that the dry products have more value than concentrates or liquids. So basically, when we are selling a hydrolyzed product, what are the market expectations or benefits of it? Basically, a hydrolyzed protein is a product really balanced that performs in terms of palatability, health for the whether for the pet or for the feed, and nutritional value. Compared to a fish oil that is more focusing on the nutritional and not that much on the palatability of the health of the individuals. So these products bring a direct benefit in terms of palatability, taste, and odor, with peptide amino acids and or use of Maillard reaction. Also could be has some functionalities for health, such as joint health, stress management, of weight management in case of the pets. In terms of nutrition, could be high protein and low mineral content because of the higher protein level and high digestibility. Then you have indirect benefits, mainly for the pet food markets, because when you are selling a product, you are thinking on the final customer perception, which is the owner. And then these are the product benefits, and let's say that when we go to the market, also other critical barriers are the supplier benefits, and that implies the quality, products, and traceability, the consistency on the volumes that could be addressed, the sustainability claims such as MSC or ASC, different certifications, the organic and clean label, and also the performance demonstration that I will explain afterwards. So basically, when we go for the market with a hydrolyzed protein, that like the ones that are being developed on this project, we can have a different value perception and the performance demonstration. So based on the difficulty to demonstrate and the perceived value by customers, so the importance of a robust supply to be capable of delivering a constant volume of product to the market, because peaks and base are sometimes difficult to manage. Also, the importance every day is more important than the part of certification and traceability and standardization. Also, the panel evaluation to prove that your hydrolyzed protein is functional and is interesting for the pets or for the aquaculture use. Also, of course, the analytical in terms of the nutritional point of view. But in the long term, what is more difficult to demonstrate is through trials, is that what are the capacities or capabilities of these products in if the individual is taking it repeatedly, and well, this is linked with requires more R&D and marketing. So basically, on the analysis we are going to make on the hydrolysates that the project made is more focusing on the first part, because we will need more attention in order to analyze these trials. So basically, from the project, the samples that we were asked to evaluate were different hydrolysates for salmon and trout and turbot. So basically, the products were quite well balanced, with an interesting level of protein, interesting digestibility that will be of good use on aquaculture and pet food as well. And in terms of the fat content, well, you can see the heads of the salmon have a higher amount of fat, but it's typical on the heads of different species. And what is true is that the fat content present on these hydrolysates is not especially interesting under the omega-3 point of view. It's not such other species like tuna or sardine that will deliver a more interesting balance on the omega-3. Even though fat is not the key part for the hydrolysate, it also could affect the perception. So continuing on the analysis on the heavy metal side, the levels are really interesting compared to other hydrolysates on the market with a quite low value of heavy metals. And in terms of the biogenic amines are also interesting because, well, if you follow properly all the logistics and you keep the temperature right, you will deliver a more fresh product and will be capable of getting a better market value of that. And for the microbiology, nothing else to say. Just to finalize on the part of the analysis of the hydrolysates, just mentioning that all the hydrolysates show an interesting value of in terms of the potential use on palatability because of the glucosamine content. And then we have the part of the molecular weight that, well, for pet food, they have could have a quite interesting use, and as well for aquaculture, but it will depend on the phase that we will use this hydrolysate. In some cases, some customers will require to have the molecular weight lower than 80% lower than 1000 Dalton, but as I said, it depends a little bit on the different applications. So just to finalize and going for the main conclusions, the hydrolysates seem interesting for the protein level, even though ideally we will have to go for reach a 80% value, because this will give a jump as well on the market, with the potential of using a de-assing process to improve the protein content up to 90%. As I said before, the fat characteristics are not extremely interesting, but they can be applied for technical use, but of course at lower price compared to other raw materials. Even though this fat content is quite low, it's necessary to use an antioxidant to avoid negative effects on palatability in the long term of the cell life of the product. And as I said before as well, the products show are quite interesting levels of heavy metal compared to with other commercial species. And the molecular weight is interesting for pet food application, and not for all phases of aquafeed, but for some of them could be interesting as well. But with the current capabilities of the CSIC, the people who make these trials, well, there shouldn't be any problem in order to work with the different profiles of molecular weight. Under marketing perspective, all the species analyzed in this project are interesting, linked to the customer perception. Basically, because salmon and turbot have a high level of perception by the customer, because when a pet food owner goes to the supermarket, well, it's not the pet the one that chooses the product that they want to eat, but it's the customer, and the customer, when they like salmon, they like the turbot, and they have a high perception of it. So they will rather prefer it to other species when they go to the supermarket because of the marketing point of view. Well, another part is the critical part is the volume. When you want to set up an industrial scale activity, you need an important volume because of the operative cost of this kind of installations. It will require critical to reach a certain volume in order to start industrial scale up. So basically, the strengths of these raw materials, the SWOT analysis of these products, I would say that the strengths are the raw material availability, which is a key part, the importance of having the raw material, the low heavy metal content, good customer perception on the analyzed species, and in terms of the opportunity, which is a high market demand for proteins and functionality products. With new suppliers getting in the market generates more interest on this sort of product, and partners are interested also in integrated supply that guarantee the source in a long term. But on the other hand, we have the weakness, which is could be in some points or some species some limited sourcing, non-existing structure or dedicated teams in the valorization, as well as the omega-3 balance that I mentioned before. In terms of threat, the aquaculture raw material perception in some cases might limit the use, the regulatory aspects, and the new players in the market that at the same time could saturate the market. So that's all for today's presentation. Thank you very much.
Thank you very much. That was great, and we're just on time. So I think we'll, unless there's one burning question, I think we're going to move on and go straight to the next speaker. And here we're talking about eco-efficient feed formulations. So that's Tiago Aires. So can you just share the screen and go right ahead? Yeah.
Moment. Just a moment. Allow me to put the screen. Okay. Are you seeing my screen? Hello?
Yes, Tiago, we can see it. Just beam it up.
And it's functioning?
Yes.
Okay. So I was asked to make a brief analysis of how can we use these results, and I did not present myself. Sorry, I'm Tiago Aires. I'm a technical director of Sorgal S.A. in Portugal, responsible for fish feeds and pet food formulation, and I got in touch with this project with GAIN 1 month ago, I think, to talk about land animal proteins, because in the company where I work, we have rendering unit, so we are quite acquainted with what is rendering both fish and poultry. So what I consider, and I had very not many time to do the presentation, to conduct the presentation, so I tried to resume a little bit the status quo. And European fish feed producers presently are subject to several constraints. I think the first one is a consumer increasing environmental conscience, meaning that consumer is more and more focusing on environmental related subjects, either carbon footprint, either sustainability of the ingredients, And this is driving retailers to demand to farmers a series of claims, non-GM, that is quite specific to fish, but also some of them no land animal proteins. The last one is no soy from deforestation or conversion, and also the presence of sustainable fish meal, etc., etc., etc. And this, of course, limits a lot what fish feed producers can do, together with the pressure to reduce effluent rejections, nitrogen, phosphorus, and to increase sustainability of the activity. But we have to consider also our conditions in Europe. So we are highly dependent on imported protein, and this for soy, for instance, is over 90% of the soy consumption. We consume around, in animal production in general, something like 34 million tons of soy, and we produce 1 million tons of soy in Europe. So we are highly dependent from South America and the United States. But also the lack of knowledge. We don't have a lot of knowledge in local ingredients, like some vegetable protein concentrates, coming from bioethanol, biofuel production, but also single cell protein. Insects is the newest one that is really on the starting stage. Another issue that is quite recent is the increasing prices. This arrived with the pandemic, but right now is getting really, really very, very serious, and we think that will be there for quite some time. Together with logistics, this is imposing to the industry a huge threat and huge challenge that I don't think we are going to escape without any harm. We are going to suffer from this, and the industry will change with this crisis. And finally, our European legal framework that is extremely restrictive, much more than elsewhere in the world, and not only on what kind of ingredients we can use, but also additives that we can use. Enzymes, for instance, are not approved for fish as they are in land animal, and this also hinders the possibilities or limits the possibilities that the industry can use. So, taking a little bit on the results of the GAIN project and what are our expectations, we expect novel local ingredients, and I think local is very important because the aim is to reduce transport, but also to increase local activity, either animal or vegetable. And the project was quite good because it proved how useful, for instance, animal protein can be. Single cell, because they are very efficient. It's something that we look at with with a lot of interest. Either for instance, for the DHA production, but also if we think about protein and some bacteria can be also of interest. And I would mention obviously also insects, but all of these must come with two important points that are reasonable costs and consistent quality. Of course, formulas and ingredients, but they must be efficient. We cannot accept, the industry cannot accept decrease of performance. For instance, as it's seen in organic farming, the restrictions in organic farming, one of the consequences they have is loss of efficiency. Also, less restrictive. We need a less prescriptive legal framework. It's not for the project, especially for minor species like Mediterranean species. Why? Because if we are going to use vegetable protein coming from for instance, bioethanol, we are going to increase we are going to increase non-starch polysaccharides, and it's quite obvious that enzymes may play a role on this. But we have to we must be able to use it, and at the moment we cannot. And finally, we must understand that our industry must be reasonable. We must have reasonable prices along the value chain, because using eco-friendly diets at a certain moment will imply increased costs. And it's not fair that farmers or the industry are going to take this burden without being paid for. And so it is for me quite obvious that something must be done, and passing this increase of costs to the chain value, and in the end, not being the farmers obliged to take it all. In conclusion, for me and as a feed producer, it is possible, not only possible, highly desirable to use these eco-efficient formulations, but three very important points must be taken in consideration. This sector cannot afford more cost increases, so we have to focus on ingredient production costs. This is quite important on insects or on single cells, microalgae, for instance. We must improve production protocols, because when we analyze the results from GAIN, one of the conclusions is that prices and LCA impact, LCA evaluation were the only parameters that were consistently reduced in performance. So this must be worked, and obviously we have to try to reduce the restrictions on land animal proteins usage, legal and animal protein usage, because it is very well proven that they are cost-effective, valuable ingredients, especially in these conditions we face right now. So this message must pass, and the consumer must understand that co-products from land animal, as well as co-products from fisheries or from aquaculture, they are interesting products, cost-effective, and I think they are the most easy to start using on a really short time, compared, for instance, with insects that are much more long-term oriented. And this is all what I have to say. Of course, I'm available for any questions that you have. Thank you very much.
Thank you, Tiago. Thank you very much for the talk. Do we have any questions that anybody would like to put to Tiago? Is there anything in the chat? I don't think so. Okay, so thank you very much. I think we'll move on. Thank you very much, Tiago. So we're about 10 minutes early. I don't see anything wrong with that, except for the fact that it's unusual. But what we're going to do is move straight on to the next talk, which is a talk that I've been looking forward to on nutrient trading and shellfish farming. So I don't know who shares the screen and who speaks first and so forth, but I'm sure that the people involved are fully aware of that.
Okay, so Suzanne's going to share the screen first, and it's a 3-woman thing, so it's good you'll have 10 minutes extra, because you know how we like to talk. So as always, we've left the best to almost the last. I'm Heather Moore, and I work in AFBI in Northern Ireland, and I had the pleasure to lead this task 2.4 in the GAIN project. Shortly, you're going to hear from Suzanne Bricker from NOAA and Alhambra Kubela from Longline, who will provide much more detail about nutrient trading and shellfish farming and why we think it offers a win-win solution. Second slide, please, Suzanne. Okay, so just as a talk overview, what did we look at in this task and why? The problem we wanted to address is that of eutrophication in coastal water bodies. Looking at the main causes, both point and diffuse, and to see if top-down control of eutrophication by bivalve shellfish can be part of the solution to the problem. Suzanne Bricker will shortly discuss this in much greater detail and introduce the US approach. And then Alhambra will talk about the details of the work involved in Task 2.4, showing how we met our goals, our approach to this, and our results that informed Deliverable 2.9 and the white paper. We set out to answer the question, can bivalve shellfish aquaculture be used for nutrient management in European seas? And I hope that by the end of this talk, you're all going to agree that it's certainly a great step forward. Thank you. And now for Suzanne.
Hi, good morning. Thank you, Heather. Before you hear the results of our study from Alhambra, I want to provide some background about why we're concerned about nutrients, nitrogen in particular, and tell a little bit about what we've done in the United States to expand our nutrient management capabilities. So nitrogen is a building block for life. However, too much nitrogen is a problem. Excess nitrogen leads to a variety of water quality problems. Nutrient pollution, also called eutrophication, is a major challenge to coastal water quality around the globe. There are many sources of nitrogen discharge to coastal waters. And we know that reductions to point sources are easier and less costly than making reductions to non-point sources. However, there is no single solution to manage them all. In the United States, 65% of the estuaries that we studied have moderate to high level eutrophication as a result of nutrient discharges. Nutrient management strategies have worked to reduce discharges, but continuing eutrophication impacts suggest that additional nutrient management is needed. And we also know that the US is not the only country to observe these problems. One concept that is gaining a lot of momentum now in many places is the possibility to use bivalve shellfish as a nutrient management measure. There's a growing body of research that has shown shellfish aquaculture to be a promising addition to existing nutrient management measures, while also providing a domestic source of seafood. The service of nutrient removal by shellfish has actually 3 different mechanisms. One is assimilation of nutrients into tissue and shell as they grow. That is the focus of our study. Shellfish can also increase loss of nitrogen from the water through denitrification and by burial in sediments. Because shellfish can remove nitrogen from the environment, states and municipalities want to include shellfish cultivation and harvest in their management programs. In the United States, this concept has already been put into action on both local and regional scales. For example, in Cape Cod, Massachusetts, the nitrogen management plan includes large-scale nitrogen removal by harvest of both oysters and clams. For clams, the town purchases the seed, grows them out in town waters, and then opens those areas to commercial harvest. Those harvest reports and also published literature on nitrogen content of local clams are the basis for nitrogen removal calculations. The plan was approved by both federal and state management agencies and is currently being implemented. On a regional scale, the Chesapeake Bay program convened an oyster expert panel to review literature for assimilation-related nutrient reduction and local aquaculture practices. The first recommendation that was approved by both state and federal Environmental Protection Agency was credit for nutrient reductions from tissue assimilation of harvested aquaculture oysters. So oysters can now be included in management plans for fulfillment of required nutrient reductions in Maryland and Virginia. These are both very nice examples of the federal and state cooperation to achieve desired water quality goals. In both cases, the number of harvested shellfish and the nutrient content is used to determine the amount of nutrient removed. So in these last slides, I want to provide more detail about the implementation of bivalve nutrient removal into our United States nutrient management programs. So again, in Cape Cod, Massachusetts, note that in 2017, the clam harvest was credited with removal that was equal to 30% of the required nitrogen reductions. In this case, both shell and tissue are used in the calculation. In Chesapeake Bay, oyster growers can be credited with 90 kilograms of nitrogen for every million oysters harvested, but only the tissue counts in this program. There is a registry for growers who have accumulated credits that can be used in nutrient management accounting in the water body or jurisdiction where their lease is located. The economic value of the nutrient removal service provided by shellfish is estimated by using costs to remove the same amount of nutrient by other management strategies. So that cost is assigned to the amount removed by the shellfish. Those alternate management strategies are wastewater treatment, urban and agricultural best management practices. These can best be thought of as the cost saved by avoiding the cost that would have to be paid for those other management strategies if the shellfish were not doing that work. In Great Bay Piscataqua estuary, the value of the nutrient removed by oyster harvest is equal to about $100,000 a year based on avoiding costs for upgrading wastewater treatment in that water body. In Long Island Sound, the value is equal to between $8.5 million and $230 million a year, depending upon whether the value that is assigned is calculated based on wastewater treatment or agricultural or urban BMP costs. So as you can imagine, the economic value of nutrient removal is of great interest, especially to growers who think that they should receive compensation for the nutrient cleaning service that their shellfish provide. In a fully operational nutrient credit trading program, that is possible, but the costs paid to the shellfish grower are always lower than the costs saved. In the Connecticut Nitrogen Credit Exchange, for example, the credit price for 1 kilogram of nitrogen removed is about $15. In the Virginia Nutrient Credit Exchange, the price is about $18. So the buying and selling of nutrient credits and nutrient credit trading programs are still in development. They're partially operational now in Chesapeake Bay and elsewhere. Though the use of shellfish bioextraction for nutrient management is already proving to be very successful in some jurisdictions in the United States. So now I'd like to turn it over to Alhambra Cubillo, who will tell you about our project results.
Thank you, Susan. Can you stop sharing?
Did I stop sharing?
Please.
Yeah,
Okay.
you need to see, we can't see your
I'll try
screen.
to share. Okay. Can you see it now?
Mhm.
Okay. Says my internet connection is unstable, but I hope it will be fine. As Susan mentioned earlier, eutrophication is a worldwide problem, and Europe is no exception. In fact, nutrient pollution has been a major issue in European coastal water bodies for decades. In the yellow dots in the map show the systems showing eutrophication problems, the red dots, the hypoxic areas, and the green dots, the systems in recovery. The primary driver of eutrophication are nutrient discharges from human-related activities. These include point sources, diffuse sources, and atmospheric deposition.
Alhambra, sorry to interrupt you. Do you have an earphone that you can use or something? Because there's quite some echo in your.
Yeah.
I'm sorry about that, but I
Sorry.
think it'll be better if possible.
Okay. Can you hear me better now? Okay. I don't know if you can see all these faces in all your faces in my screen. Okay, we do it like that. Okay, so to date, the nutrient reduction strategies have mainly focused on point sources, but these nutrient reductions have been proven to be insufficient, and additional nutrient management is still needed in Europe. In our study, we focused on nitrogen because this is often the nutrient limiting primary production in coastal waters. We reviewed the nitrogen discharges to the different European seas based on if they come from point sources, diffuse sources, and atmospheric deposition. I won't go into detail here, but as you can see, the greatest proportion of these nitrogen discharges are diffuse, which as Suzanne mentioned earlier, these are logistically more difficult and costly to control than point sources. The reduction of diffuse sources typically imply substantial changes to agriculture and livestock management, leading to serious social and economic consequences in rural areas. What we propose in task 2.4 is to use bivalve shellfish aquaculture to offset the consequences of this excess nutrient loading. Bivalves feed on this primary production, removing the nutrients from the water column through their filter feeding. This is called bioextraction capacity, and this way bivalves short-circuit the secondary symptoms of eutrophication. This is considered to be a key regulatory ecosystem service that contributes to the control of eutrophication effects. The main question we wanted to answer in task 2.4 is if bivalve aquaculture could be used in nutrient management programs in the EU to complement traditional land-based strategies in a similar fashion as they do in the US. Among our goals, the first one was to evaluate the net nutrient removal by current shellfish aquaculture in the EU. For that, we estimated the nitrogen removed by the top 5 shellfish commercial species using 2 approaches: through elemental analysis of nutrients in shellfish meat and shell, and using physiological and local scale models to simulate the nitrogen removed by the whole farm population at the typical farm over the whole culture cycle. Then we reviewed the European shellfish production for these top 5 commercial species to upscale this nitrogen removal to the EU scale. As we saw earlier, we also reviewed the nutrient loading to the different European seas so that we could assess the potential of shellfish aquaculture to offset these nutrient discharges. And we used the cost of removing nitrogen by alternative management strategies to value this ecosystem service. That is the potential compensation that farmers would receive if shellfish were included in these nutrient credit trading programs. The final goal of task 2.4 was to develop a framework proposal to include shellfish regulatory services in nutrient management programs in the EU. But how much nitrogen can bivalve farming remove? This figure illustrates the estimated nitrogen removal in kilograms of nitrogen per ton of harvested shellfish for the 5 species analyzed, using both approaches. In blue, the modeling results, and in green, the elemental analysis results. As you can see, the modeling approach provides higher nitrogen removal estimates for the 5 species. And the reason is that the analytical approach estimates the nitrogen removed by the average harvestable size individual, while the modeling approach considers the nitrogen removed by the whole farm population. Our results showed that the nitrogen removal depends on the species, the environment, and the culture practice. Things as the stocking density, the culture system, or the length of the culture cycle affect this nitrogen removal. In the modeling approach, we use the culture practice at the typical farm, and we assume that this applies to the whole EU. Our results should be considered as a conservative estimate of the true value of this ecosystem service, because we are only considering the nitrogen removed in shellfish tissues through harvest. And we are not considering the nitrogen loss due to denitrification or permanent burial in the sediments. We then reviewed the bivalve aquaculture production in the EU by species and country so that we could upscale this nitrogen removal to the EU scale. Our 5 selected species account for 95% of the shellfish farm production in the EU. We have that Spain and France are the largest producing countries with 42 and 24% of the total shellfish production in the EU. As you can see in the figure, the med mussel is the most abundant farm species, while Pacific oyster is the most profitable of the 5 species analyzed. This table shows the nitrogen removal for the key species and EU producing countries given in tons. The total nitrogen removed by these 5 species in the 28 EU countries range from 5 to 13 kilotons in 2018. We have that med mussels are responsible for the highest nitrogen removal, accounting for 64% of the total nitrogen removal. These are followed by blue mussels and Pacific oysters. When we look at the countries, we find out that Spain is the country responsible for the highest nitrogen removal, accounting for 46% of the total nitrogen removal. France, Spain, and Italy together accounted for 80% of the total removal. Now, what's the economic value of this nitrogen bioextraction? Current EU bivalve farming removes the nitrogen equivalent to water treatment for 1.5 to 4 million people, depending on the approach used. The economic value was estimated based on the cost of alternative nitrogen removal strategies. The ones considered in this study was the implementation of stormwater control measures or agricultural best management practices, and also the upgrades to wastewater treatment plants. The benefits of incorporating shellfish aquaculture into nutrient management programs range from 18 to 48 billion euros in 2018. From our study, we concluded the following. Bivalve aquaculture associated nitrogen reductions in the EU are significant and consistent with removal rates of other approved best management practices. The bioextractive capacity of filter feeding bivalves is an economically valuable ecosystem service that can help reduce difficult to manage diffuse discharges. The major challenge is to quantify this nutrient removal, because this varies among species, environments, and culture practices. And finally, the lessons learned in GAME have identified a potential approach to develop an effective nutrient management plan that includes shellfish growers in the EU. We all would like to thank you for your attention.
Thank you very much. That was almost the time anyhow, so you didn't end up eating into the 8 minutes that you still have left. So there's time for some discussion if people want to make comments or ask questions. And so I'll open the floor again, either on the chat or just shout out, which is much preferable for me.
Yeah, I'll shout out then, Joel.
Go on then, Anton.
So a couple of questions. Alhambra, in your final modelling there, or in the final numbers that you put up about the valuation, were you using the model numbers from IBM, or were you using the actual values that you obtained during the research process?
We were using the values that we obtained using our own model, individual-based model.
Yeah, I'm sorry, Anton. I was just clarifying. This is not IBM, the company. This one, it's a different thing. It's IBM as in an individual-based model.
Individual-based model.
Ah, thank you. Okay.
But I think you have both, right, Alhambra? You've got the numbers have a range between just approximate analysis. So that's the lower
and
numbers, Anton, and the model results. Yeah.
Yeah, they were the bars, the blue and the green bars on the graph.
Does the model need to be updated because of the approximate analysis results? I might just be me being ignorant on the modeling, but
can I take that one? Or do you want to do it? You do it, Alhambra. You do it.
No. You do it, please.
No, well, no, I'll just say this. So what Alhambra said, the model calculates based on the whole procedure of cultivation. So there are animals that are left in the water. The symptoms are not in the water anymore. In other words, the phytoplankton and detritus, because that's been filtered out by the animals. So effectively, the service is there, except the alternative way of calculating it, which I suppose is the simplest one, is just by doing the calculation based on the tissue content of the harvested animals. And that's what Suzanne showed for the States, and that's what the approximate analysis is. Suzanne?
Yeah, and so if I can comment on that, in New England, in the Cape Cod, Massachusetts case, they include both shell and tissue content, nutrient content for both clams and oysters. In the Chesapeake Bay, because shell is such a commodity, and also they move it around. And so what they decided was that they were more interested in having the shell go back in the water. So they only credit nitrogen and phosphorus removal for tissue alone. And it is also determined by the nutrient content of the tissue. That's the legally, because there was some concern about the variability that we saw when we were doing the modeling. And so that's not to say that we won't at some point have a model that will be also used for that purpose. But for now, the legal definition is the removal of the harvested tissue of the oysters.
And that model can vary by state, I guess. And that's partly, as you explained there, because of the use of the organism, different parts of the organism in that state.
Right, and so each state is developing their own way of doing it. And the Chesapeake Bay is the biggest and is the only regional program right now. It's also the furthest developed. And so, for example, there actually has been, and I didn't want to spend the time to say this, but there have actually been 2 payments to growers. One was a voluntary payment by the Baltimore Convention Center because they bought some oysters and they blasted it all in the newspaper to make sure that people, first of all, knew about the concept and knew that they were a conservation-minded company. And then the other one was an actual offset for stormwater discharges, and that was paid to a grower from the same water body where the discharges were going into. And so that was included in the accounting that's required for nutrient reductions in that water body. If that makes sense.
Yeah, thanks.
Any other points that anybody would like to make? Questions? So I would just like to make a couple of general points on this. The first one is that so the intent here was to try and get Europe, European Union, but Europe, let's call it European Economic Area, to start thinking along these lines in terms of policy making, because this is an area where I think Europe has fallen quite a lot behind when compared to the United States. And so it's clearly an area where we could benefit from the experience from the US, and in the context of the Galway Agreement, which is one of the things that we put into GAIN. This is where we have some leverage and therefore take advantage of the work that Suzanne kindly contributed from the point of view of the experience in the States. So this has helped us a lot. I'd like to sort of think of two other points. Maybe Heather can help a little bit with this one. The first one is where in Europe these kinds of things might be trialed. But before you get to that, there's a thing that I think should be said, which is we try to scope out what the overall general value of such an approach might be to Europe. But that doesn't, and so Alhambra showed some results for France and Spain, particularly as being the countries with the biggest impact. But that doesn't mean, and this is a kind of lead in for you, Heather, as well, I think, that in places like Northern Ireland, that at the local scale, these things might not be important to individual growers, because it's a very challenging time for this kind of activity, and the pandemic hasn't helped at all with that. So there are, clear local things. Some of the examples Suzanne just gave were quite local, that may make a difference to local growers. So it's just something that can be seen in those two perspectives, sort of coming from the macro and also at the micro level.
Okay, so from the Northern Ireland perspective, I mean, a lot of the things that are limiting the sustainable sustainable increase in aquaculture, because if it's not sustainable, it's just not being allowed. I mean, we're seeing that in other parts of the UK with Pacific oysters and things like that. But I mean, one of our biggest issues would be water quality problems. So I think there is a real space here for this kind of thought process. I mean, we were saying it's part of the solution. Obviously, the bigger part of the solution is they don't actually pollute in the first place. And I mean, there's been a lot in the local press about that and in the UK press about that, and a lot of bad feeling about government ignoring CSO spills, which is combined sewer spills. But I mean, our aquaculture industry in Northern Ireland suffer greatly from poor water quality. So the idea of improved water quality and them being part of the answer is certainly something that we will be going forward with, and we will be taking to our policy leads. And I think there's lots of other places. I mean, obviously, when you're looking at the table of stats that Alhambra's pulled together, there are parts of the world where this could have a bigger punch, if you like. But I mean, we are certainly taking it to our policy leads as something for them to consider.
Okay, is there anything else from, okay, Suzanne?
Yeah, I'd just like to make a comment about the Chesapeake Bay program. Oyster expert panel that did the review of the assimilative capacity of oysters. Two things. One is that denitrification is being included and will be recommended also for crediting, but that will probably come out only next year. But the important part about that panel is that it was funding was found for the creation of the panel only because of the pressure from oyster growers in Maryland. And Maryland, the Maryland legislature found funding then to put that panel together and to do the review of the assimilative capacity and also the denitrification. So in your model, Heather, when you're talking about the resource people, I don't know what the grower cohesiveness is there, but I would suggest that you always put pressure on legislators that you could then form a kind of pincer movement to make the research happen and maybe make the implementation happen. because that's basically what happened here.
Dave, let's have one last question then, so I can move to the last.
Very quickly, just the three of you, I think it was fascinating, and I just wonder where you see the policy wiggle room, as it were. I mean, we have environmental stewardship funded programs for land in the UK. How can we use this as to make a case that actually we need the same for coastal waters, and surely that can be made part of the case for support for expanding shellfish aquaculture?
I'm not sure if Suzanne or João have any ideas. I mean, we're firstly going to present this to our policy people in DAERA because they're in charge over here. But how it would actually go up through, Dave, really, I don't know. But I mean, yeah, you're totally right. There's a lot of, I mean, there is a bit of a movement in Northern Ireland now, looking at catchments specifically, and looking at the priority of the whole catchment to coast ecosystem modelling. So based on a lot of that work that we've done in AFBI, there's a lot of movement towards targeting sources of pollution and stuff like that. And there is some, I can't think of the correct names for them, but they're mainly agricultural, yes, grants and things like that, about trying to stop what's happening in the catchment and therefore reducing the impact of it on the coast and on the water bodies such as shellfish waters. And that again is pushed by the work that we've done in GAIN and work that we've done within AFBI. So I can't tell you we've got a definite way to do it, but I think that all the work we've done in GAIN and the ecosystem modelling work that we've done is certainly providing enough evidence to show that we need to do something.
Mm-hmm. Yeah, I think in the interest of time, we'll leave it at that. It's a conversation that could go on. It's fascinating sort of development to look forward to. I'm going to do something that I've never done before, at least completely out of character, which is to actually cede the chairmanship of this session over to Roberto. And the reason I'm going to do that, of course, is because the last 10 minutes are his for the legacy program. And then I think it'll be an honor to have him close this public final meeting. Before I do that, I'm also going to do something that's not usually done on Zoom, which is ask everybody to help me thank Roberto for everything he's done so far by giving him a big clap on Zoom.
Yay, Roberto!
Yeah.
Yay!
Hey.
Awesome!
It's been a tough year. Well, 3.5.
Thank you.
COVID.
Thank you very much. I will try to be short in concluding this meeting, which I hope it was successful and informative, in particular for the people who were not part of GAIN, but got probably, I hope, an overview of what we did. We are at the end of a long journey, a journey that, in fact, I started even earlier than the others, because we started thinking about GAIN with João and Johan, I think in a restaurant in Edinburgh about 5 years ago, in the autumn of 2016. It was, the writing was a long process. It was a two-stage call. We then met some other people who were enthusiastic about our ideas. We shared a lot of ideas in writing the proposal, and this was already quite an enrichment process for me, in which I learned really a lot of things. I learned a lot of things also all the way along the project, and I think that we all learned something from each other during these 3.5 years. So I am very happy to have led this project. I have a mixed feeling now. I am pleased that it's nearly over, because it's also a commitment to be the coordinator. But at the same time, I'm also a little bit sad that I'm not going to work with all these nice people in the next few months, but I'm sure that there will be other opportunities. So about the legacy, I think that when we design GAIN, some of the topics that are now being investigated by quite a lot of other European projects, such as circularity and let's say precision aquaculture or digitalization of aquaculture definitely were less explored. So to some extent, I think that we developed some ideas at that time, and we tried to bring them forward in a context which was slightly different from the context that we have now. The results that we have got, I believe they will be useful for the ecological transition on aquaculture, going back to the contribution of GAIN to the Green Deal. Definitely what we did can be developed further and improve the digitalization of the industry in the next few years, and the transition towards a more circular economy. But I would like to perhaps say a few words starting from what Dave said in his talk and from some of the apparent, let's say, contradictory results that LCA sometimes can give. In my point of view, my background is physical chemistry and thermodynamics. The ecological transition can be realized only if first we have the energy transition. There is no free meal. That's the main message of the second law of thermodynamics. And if you want to recycle, you need exergy or free energy or chemical free energy. So you need renewable energy if you want to convert some type of matter in another type of matter. And unless this is realized, some of the indicators that can be derived from LCA may not be as favorable for products which come from recycling as it might appear at first sight. Having said that, I think that what we have got, the result that we have got can be further exploited. I think that this afternoon we saw a few examples, but there are other ones. And I hope to be working on that side after the end of the project. Now, just let me thank a few people. People tend to forget always somebody when one does that, but I will try not to. First, of course, the participants to this meeting who listen to us, and they are encouraged to contact us in case they have further questions. Of course, all the deliverables will be on our website once they will be approved by the Commission. We have also the YouTube channel in which you can also access some materials that were produced for dissemination during the project, and also I think this meeting will be recorded. Then of course the partners who worked together to achieve the goal, the common goal that was set at the very beginning, and then my team, which included also Serenella and Chiara, who assisted me in the everyday management of the project. We were also supported by a very nice advisory board who guided us and gave us some nice suggestions to reorient the project whenever it was necessary. And the review panel. The review panel, we went through the 2 review meetings. We will have the 3rd one, and they also were very helpful in reviewing our intermediate results and providing us suggestions to further improve our work. I think that that's all on my side. So, grazie a tutti. Allora.
Thank you, Roberto.